As begin as start as we begin to explore quadratic functions, the first thing I want to talk about is vertex form. So I guess we need to talk about what is the vertex. Well, so first of all, here is the picture of the lights at my friend's house. So see if I can trace this briefly. Not bad. Okay, so the vertex is the point on the bottom of the curve, right there. That's our vertex. Okay, it's the place where it's a turning point where the down is no longer a down; it starts to be an up. Okay, so a turning point is the vertex. As we look at the picture ahead of the fountain, here's the path of the water splashing into the pool. And once again, the vertex is right there. And what I want you to notice is that the shape of the parabola, it's symmetrical. What you should notice that if I had a mirror cutting down the middle of my parabola, that this side over here and this side over there are the same. Okay? So that's important to note with parabolas, the shape that these things make. Okay, here's another one that I'm sure most of you have seen before. There's a beautiful parabola. Oh, there's another parabola right beside it. And once again, here we are right at the top. This is my vertex. Okay, and one more. Here's the Halifax Bridge. Okay, so this is the McDonald Bridge connecting Halifax to Dartmouth. And you'll see this beautiful night view. But right here, that is the vertex as we look at the McDonald Bridge. So what we need to do next is start looking at how we can describe these. And we're going to start by looking at what's called the vertex form. So vertex form as a function, we could write this f of x, which you learned to do in Math 10, but we'll just write it as y equals. And what we're going to do is we're going to put numbers in these three blanks. That's what we need to do, is figure out what numbers they are. The number in front is always an a, and these numbers are going to be h and k. And h and k represent the coordinates of the vertex. Okay, so in this example here, the vertex is at 0, 0. So in this first example, h equals 0 and k equals 0. So if I wrote what I would refer to as a genetic form of the function, I would say y equals a x minus 0 squared plus 0. And you would probably understand it if I simplified this a little bit and said that this is just y equals a, x minus 0 is just x, and then nothing else. Okay, what we need to do, the last step, is we need to figure out the value of a. And to do that, we're going to have to use our algebra skills, and we find any spot on the graph that works. Like I see that spot there, it goes right through a coordinate. That's a nice, easy one. I could use that point there. I could use that point there. I could use that point there. You notice they're symmetrical. There's the symmetry of this. This point here is at 1, 1. So I think I'll pick that one. I could have used this one over here at negative 1, 1. I could have used this one up here at 2, 4, or negative 2, 4. I could pick any of these points, but what I'm going to do is I'm going to put these numbers into our function. So if this is x and this is y, I'm going to say y is 1. I don't know a. X is 1. And now what we can do is we can solve the equation. I would say that 1 equals a times 1 squared, and 1 squared is just 1, so this is 1 times a. We typically write the numbers in front of the letters. So divide both sides by 1. I'm going to see here that a is 1. So the function of this equation is equal to y equals, and I take that 1 and put it right here. I put that 1 right there, and I would see that y equals 1. And if I wrote it out completely, it would look like this. But obviously, I'm going to simplify that to say y equals x squared. Let me do another example for you. So you're going to see in this, I'm going to keep going back to this vertex form of my quadratic. There it is. And once again, what we need to do is we need to find three numbers, a, h, and k. Well, I see that this one has coordinates of 5, 4. And so therefore, h is 5, k is 4. Now, I have to be super careful with this negative sign, okay? The negative sign is part of the formula. So I'm going to say y equals a x minus h squared plus 4. Done. That's quite easy. Now I need to find the a value. So once again, a is found. So let me just say that again. We are going to find a. Once we find the value of a, all we're going to do is we're going to pop it right in there and I'm done. Okay, so to do so, I need to find a nice easy coordinate. Oh, I like that coordinate right there. That coordinate is 7, 6. Let's just do a different one. Let's do oh, that one there looks pretty good. I don't think that one's right on the line. It's not the best one. I need to have an exact coordinate. That one's pretty good. Let's do that. It's going to give me smaller numbers over here. So this is at 4, 7. Oh, and I wrote the other one. Be careful I don't get my x and y transposed here. Look at that, or I'll get the wrong answer. So this is over at 6 and up to 7. So that's going to be 6, 7. Okay, that's a little better. All right, so to find a, all I'm going to do is I'm going to take the equation I had here, y equals a, x take away, bear with me here, so used to writing it in vertex form. So I'll do it in here. So y is 7, x is 4. So all I've done is I just took this equation that I had right here and I rewrote it, but I put in the values of x and y. Okay, so this is just one of the points on the curve. So there's the x and the y. And so now I'm going to solve that. So let's see. So 7 equals a times -1 squared plus 4. Algebra, subtract 4 both sides. And what I end up with now is I end up with 3 equals a times -1 squared. 3 equals a times 1. So here we go. So a is 3. So once again, I'm going to put that value in there, and that's our final answer. So let's write that in a nice bright color here. I'll go purple. So y equals 3x minus 5 squared plus 4. There's our final answer. I'll do one more example, and then it's your turn to do some practice. Okay, so find this one. Okay, so I need to know that spot there. So that's at -5, -6, -7, -8. And how far? Oh, that one's down. 1, 2, 3. -8, -3. So once again, h is -8. K is -3. Now, once again, be super careful of the negative sign here. What we're going to end up with is, I'll do this one in blue, y equals a x minus -8 squared, take away 3. Okay, so I've got subtract was part of the function, and I have a -8. So when I put that together, I'm going to have y equals a x plus 8 squared, take away 3. Okay, now what I need to do is find A. Okay, so to do that, I'm going to find any point. Oh, I like that point right there. That's a nice, easy point. That is negative 7, comma 0. Okay, so maybe I should take a harder point. Man, should I take a harder point? How about that point right there? Sure, let's take a harder point. So that one's going to be negative 6, comma 9. Once again, any point that we know the exact coordinates, we're going to do. So negative 6, comma 9. So y is 9. I know A. I don't know x. X on this one is negative 6. And plus 8 squared minus 3. So once again, I just took this equation, I rewrote it, but I put negative 6 and 9, the coordinates of any point on the graph, into it. Okay, so let's take a look. So now what I have is I have 9 equals A times negative 6 plus 8 would be a positive 2 squared, take away 3. Okay, 9 equals A times 4, take away 3. Make sure we do our algebra in proper order. I'm going to add 3 to both sides. And now I have 12 equals A times 4. I usually prefer to write the 4 in the front, but we're going to divide both sides by 4 anyway to get the answer. And now what we see is I have 12 divided by 4 is 3 equals A. And that's really helpful. So all I'm going to do now is put that back into my equation right there. So let's do our final answer in, let's go for green here. Y equals 3x plus 8 squared, take away 3. That's vertex form.